This is an example of how we would make something like a ID card or an insurance card, something like that. It would end up looking like this, like with photo and the name information, maybe an ID number, and some dates like expiration and issue date. And then we want to encode some additional stuff into the chip, like social security number, account numbers, personal information that you don't want to print on the card will go in the chip. So let's go through the steps of how you would do something like that. For our sample insurance card, I've chosen the data items that I want to put on the card and in the card, and I divided those data items into two categories, print and encode only. So for print and encode, because we're printing it, we need to save information like font names and font sizes and position and X and Y and layer number that we want to print it to. And then the encode only data, because we're not printing it, we're only writing the data to the card, we don't need all that extra information. So we have another section of CE where we can just tell it where in the chip to write these pieces of information. So here I've also made a note of how much size I want to allocate in the card file structure for each item. So I'm allowing 30 characters for the name, first name, 20 for the middle name, and 30 for the last name. And then dates, if I write the dates in this format, let's take the parentheses off there. If we write it in that format, we only need eight characters, but let's say we wanted to put slashes between the year, month, and date. We might want 10 characters, so I allowed up to 10 characters for the dates. And ID number for this sample is 12 digits. And the ID photo, we're going to allow in the card file structure up to 20,000 bytes for the photo. So then the code only section is same idea for the dates, allow 10 characters. I'm allowing up to 50 characters for the address and city, 30 for the state, 30 for the country. Okay, so employer name could be bigger, so we allow 70 characters in there. And insurer name, that could be larger, so I'm allowing up to 70 characters for those items. Okay, insurance account number, who knows, I'll just allow 16 characters. Okay, I've opened up M.O.S.T tools now so that I can create a card file structure or a .cfs that has a structure that matches the data we want to write to the chip. So I'll start by going File, New, and we'll call it Insurance Card. I'll just reuse the previous name, that's alright. Okay, and I'm going to tell it it's a C7 chip. Okay, so I'm going to organize this card into two sections. The first section, I'll write make a DF at address 4000, and that's going to be a place for the card holder personal information. And I'm going to make another section at address 5000, and that section will be for the insurance information. And since we want to protect our files from being overwritten or hacked or whatever, we're going to add a CHV password. And I'll just do a random set of hex bytes by clicking on the random button. And we'll just add one to the other DF section. So those are local to those sections, and the other section can't use it. So all the files in here have to use this CHV password. They can't use this one, and this one can't use those. Okay, so now I'm going to add places to store the information. So in that directory file 4000, let's add an EF. And I'm going to say this one's for first name. And I want to allow up to 30 bytes. I want to write, protect, and update protect it with that CHV password. And we'll let it be read always because we don't need to protect it from being read, just from being overwritten. Okay, now I'm going to pause the recording and add the rest of the files. Now I'll be right back. Okay, I finished adding the files, so we've got a place for first name, middle name, last name, expiration date, issue date, ID number, and ID photo. And you can see ID photo, I've allowed 20,000 bytes there. Okay, and then in the insurance section, I've got the date of birth, address, city, state, country, phone, emergency phone number, employer name, employer address, and insurer name. But I stopped there because I wanted to show one thing. The insurance account number is something we don't want to allow to be hacked. So I'm going to add an additional security item for that, and that's an app password. Add app. So we click on DF5000, add app, and I'm going to make a random 20-byte app password. And that's a local app password. It requires an authenticated session, and it's more secure than CHB because CHBs travel across the wire and they can be sniffed, and app passwords don't. They're more secure. They're a little bit slower to process files, but they're more secure. So I'm going to add the final file here is the insurance account number, and that's going to be a 16-byte file, but instead of using CHB, I'm going to use app protected. So that'll require the app password authentication sequence to be able to write to the insurance account number. So when you click on these, you can see what the read, write, and update protection is, and I'll click on the account number. You can see that's protected by an app password in 5090, and here's app 5090, and it shows the hex bytes, so you need to write those down to use in your code. So now that we've created the card file structure we want, let's write it to the card. So we put a limited life card in the reader, and we've selected file reader setup, and we've chosen the reader that we want to use. So do format, write to card, and it's saying I got the C5 instead of C7, so I had to switch to my C7 card. Now format, write to card. Okay, after it's written, we hit format, verify file system. It'll check to make sure all the files got written correctly and make sure it all says passed here. So it says all the files we put in here are now in the card. Okay, for card encoding engine to be able to use the new CFS we just made, we need to put it in the card encoding engine card files folder. So it's C:, card encoding engine card files. So we need to put that new CFS in there. So we have to go get it to where M.O.S.T tool saves that file, and that's under, if you go to this PC documents, CardLogix card tools, M.O.S.T tools, card files. Sort by date, and your new CFS will be at the top. Copy that, right click, copy. Now let's go back here to C:, card encoding engine, card files, and we'll paste it in there. And it'll be a lot easier for card encoding engine to find that. Okay, back in card encoding engine, if we want to set up our connections to our data to our CFS, we go to the connections workspace, and because this is the M.O.S.T card, we'll open the M.O.S.T card panel and ignore that's already there. We'll go to load CFS and put our new CFS in there, and it'll show the CFS files on the left and the name of the data objects available on the right. And if we look at our list of data items, we have first name. We'll move that, we'll connect that to 4040, and middle name here, last name, and let's see, expiration date, that'll go here, ID number here, issue date went there, and the ID photos down further. When the file number turns green, that means it fits, so it's okay to connect it there. Okay, so now we've connected all of our print and encode items from the first DF, from DF 4000. And now we're going to do the encode only section, but because it's not printable, like database, date of birth here, where'd it go? Okay, right there. Instead of dragging that over there, we'll go to set up to the encode only data settings. And these are 50 encode only locations in the database where we can put data to be written to the chip but not printed. So the first one we have is date of birth, and that will go into 5040. So we'll tell it here 5040, and we'll type in a description, date of birth. Okay, the next one is address. Okay, I'm going to pause this video and fill in the form and come back. Okay, I finished filling out the form. You can put whatever you want in the description. It's just for your own information. And we put the name of the EF file that we want to write that data to. The tag section is an optional thing. If you want to put a tag in front and after your data, like you wanted to do, like DOB. So it write this and then your date of birth, and then at the end it'll put slash date of birth. So that's just an optional tag if you want to tag your data. That's especially important if you want to write more than one object to the same file. So if I put 5040 here, like a few items here, oops. Okay, so that would mean write all three of these pieces of data to the same file. And the only way, well, the best way to separate that when you read it back is put a tag in there. So maybe we do the XML style address. You don't have to put the ending tag, it just puts the same thing plus a slash. Okay, so that would put date of birth and then the data and then slash date of birth. Address tag, actual address, and then slash address. So that way when you read it back you could split the data up sensibly and figure out where things are. But that's just an optional tag, you don't need to use that. If you're putting everything in its own file, you don't need a tag.
From Donna. Wanna read it or ignore it?
Fuck. So we also have an optional tag. It's really an XML tag option. So if you wanted to put several items in the same file, like I'm showing here, these three items all written to the same file, you need some kind of a tag between your data so you can separate it. So the tag system, let's say you're using the XML style, so you put date of birth. So it'll write that in front of your data, and after it writes your data, it'll put a slash version of that to show the end of that information. So then we'll put like address, city. So those three pieces of data will have tags before and after the data in the same file. But if you're writing everything to its own file, then you don't really need a tag. So it doesn't really have to use the XML style. You could put like 001, 002. I mean, you can just put anything you want here, really. It's just when it writes the first tag and then the ending tag will have a slash in front of it like in the XML style, so just keep that in mind. And you have to allow for a little bit of extra room if you use tags, because not only you have the data, but you get the tag too. So if you write a really long tag, it's going to need a lot more room in the chip.